Hello, welcome to this video lesson for CPI 111. We're going to start where we finished in the last section, which was that we introduced the idea of a finite state machine and we set up a move state for our player. Functionally, it's just exactly the same as what it was before we set up the move state. We're just rearranging things in order to allow us to more easily and sensibly and logically arrange our code so that if we are moving, for example, all of our movement work takes place inside the move state. And if we're doing something else, then all of that something else will appear inside some other state. And as a reminder, to set up our finite state machine for the RPG game, we're following a very specific approach, which is to use these user events coupled with an enumeration in which we list the states that we want to use. Now, you'll see here that with my player in the create event, I've created an enumeration called player with a move state in it, a move in the enumeration, and an attack, and as a reminder, this is equal to 0, and this is equal to 1, right? And what we're doing here in the create event is just setting us up so that we're going to run the move state when the game starts, which is all the way down here at the bottom. State equals player.move. So I've set the state equal to player.move. Then, if I go into the step event, I am calling the user event using this built-in function, which basically says, hey, run any user event that I tell you to run. In this case, I want to run the one that is stored in the value of the variable state, which we just set to player.move, which is 0. So it runs move. Great. And then in the move state itself, we take care of all of the movement. This is all the stuff we had earlier inside our step event. We moved it all in here. Okay, so that's all set up. But in the create event, you'll see that in the enumeration for player, we do have a second state, which is the attack state. So what I want to do is create that set of actions that will occur inside the attack state. And we're going to need to do several things, not just set up the actions that we want to occur within the attack state, but there are some other things that we need to set up in order for it to work. But let's start off with the easy part, which is to add an event, other, and user event, and this is going to be user event 1, which is going to be the attack state. Right? Anything we want to do related to our player attacking an enemy or attacking a bush is going to happen here inside this attack state. Before we move any further, let's start to set up some of the other stuff that we're going to need to have in order to allow our player to attack. All right. First of all, we have a collection of sprites for our player going all the way back to the beginning of this collection of lessons. You'll remember that the first thing we did was go out onto the web, use an RPG sprite sheet creator to create our player sprites, right? You know, we've already got all those set up. And I asked you, when you did that, to also set up the attack sprites. Right? And in this version I've got here, I haven't yet fully set these up, I don't think. Oh, this guy looks right. He's got the bottom center. He's moving correctly. So let's take a look at these to make sure we've got them right. So when I created the original player sprite sheet, I gave the player a long sword, which was a sort of big-sized version. And way back when we we were creating that sprite sheet, I talked about the use of the onion skinning tool in order to align all of these player attack sprites so that the feet basically are all in the same location from frame to frame to frame. So you can see that's how we've got all these set up. Okay, they're already done. And in addition to arranging the frames of my attack image up and down and right so that the feet all line up, I also want to place the origin point for each of these different versions of the attack sprite so that the origin point is at the bottom of the picture, right where the feet come to an end and placed between the two feet. It's not important, and you do not need to have the actual numbers of the origin be the same across each of these images. In fact, they won't be. You can see here they're in a different place. But what is important is that they are underneath the feet and that they are roughly centered between the two feet. Okay, so good. So we've got our player attack sprites all set up and ready to go. So one of the things we need to do if we're going to change from a move state to an attack state for our player is to make use of the array that we created earlier. And in fact, we're going to have to update this thing some. All right. Right now in the project, it works well to have a one-dimensional array, and each slot in the array is pointing to a specific image that we want to show out on the screen. And this works fine if the only thing we have to work with is just the player moving around. But now we want to add in a collection of other sprites as well. We are going to have the attack up, down, and right sprites that we need to add in. And you'll see that it doesn't really work, right? How are we going to use this system? We've already filled up 0 through 4 position using these. I guess I could create sprite 5, sprite, I guess 0, 1, 2, 3, sprite 4, sprite 5, but that goes against the whole concept of using this nice enumeration in order to set this up. So how can we do it? How can we add in references to the attack sprites? Well, here's how we can do it. I'm going to update this array from a one-dimensional array, which this is essentially a collection of these values that are going from 0, if I think of this as a big column of values with a number of rows. This is column 0, row 0, column 0, row 1, column 0, row 2, and so on. I want to change from a single-dimensional array to a two-dimensional array, and I'm going to set it up like this. I'm going to say player dot move, comma, dir dot right equals sPlayer run right. So what does this mean? Well, we've got this enumeration with move and attack. Move is in position has a value of 0, as does right in the direction one. Right? 0, 1, 2, 3, 0, 1. So what I'm saying here is that in the two-dimensional array, in position 0, 0, store a reference to the sPlayer run right sprite. Copy that to save myself some time. And paste it in. Oops. Making sure that I don't mess up my pasting. There we go. So now we've got 0, 0, we have 0, 1, 0, 2, 0, 3. So we're sort of moving row by row by row, just like we did before when it was a one-dimensional array, but now we're specifying which column are we placing these in. So what does that allow us to do? Well, it allows us to do the following. these are going to be the player move sprites. I'm going to copy all of this, come down below it, paste it in, and now we're going to have player attack sprites. And I'm going to change this from player to move to player attack. Copy and paste them in, like so. And instead of player run right, player run left, or player run up, we want player attack right, whatever it is you've named yours. Hopefully you've named them the same way I named mine. If you named yours something different, that's fine. Just make sure that you put in the right names. So now we're saying in this two-dimensional array, in location 1, 0, so this is now column 1, which is the second column in row 0, place the attack sprite. Column 1, row 1, column 1, row 2, column 1, row 3. Cool, right? So now very quickly we can begin to create a more expansive lookup table that we can refer to depending on the state that our player is in and the direction the player is facing. We can show the correct sprite. This part here is still the same. We're still initially going to have our player in the move state. Okay. Because we have changed this array from a one-dimensional array to a two-dimensional array, we've got to be careful that in our step event, when we're updating the sprite index for the player, that here we correctly update this as well. And how are we going to update this? Well, we're going to say that we want the sprite index to be equal to whatever is the value we've stored in state, and then whatever direction we're facing. And state is either going to be 0 if it's move, or 1 if it's attack, which corresponds to the idea of well, move and attack, right? So that will correctly grab the right sprite out of that sprite lookup table. All right, well, that's one piece of what we need to do. There is a whole bunch of other stuff as well. One thing we can do that won't quite work yet is to come into our move state, and we have already included in the code for the move state a check to see if the player is pressing the X key on the keyboard. And we're saying that if that is the case, that means they want to attack. So we're saying attack input is going to be set equal to yes or no, have they set or have they pushed the X key. Okay. So if we want to react to that and effectively switch from the move state to the attack state, what we can do is come down here and say if attack input equals true, meaning they've pressed that down, then what do we want to do? Well, we can say image index equals 0. This will just make sure that we move back to the first sub-image associated with the player's sprite. And we'll update the state. State equals player dot attack. All right. So if we start off in the move state, while we're in the move state, if they press the X key, then we make sure we show the very first image within the collection of images, and then we set the state to be attack. And right now we got nothing in here. Nothing happening. Well, let's take a look at it anyway and see what goes on. All right, here's my player. He's cruising along. If I start moving up and I press the X key, oh, hey, now we have a sword. But I can't move, and we can't change our image. We can't do anything. But it is correctly showing the player attack image that we want to show when the player is moving up. This is a way of telling us we have actually changed from the move state into the attack state. And the fact that I can't do anything makes sense, because here in our attack state, we've not done anything. We're not set up to do anything. Okay? Well, that's all great. So what is it we want to do inside the attack state? Well, we want to attack. And the way we're going to attack is we want to have the player be able to swing their sword and to hit something. So let's start with the swinging the sword part. Right? One thing we can do that's real easy is that we can, inside here, say image speed equals 0.8. Right? If you remember here, there are times when we might have the image speed equal to 0, right? And the image index equal to 0. And there are times when we have the image speed equal 1 if we're playing an animation as the player moves left, right, up, or down. When we come into the attack state, we don't actually want to allow the player to move when they're in the attack state. In fact, we're not going to let them move. They're going to have to stand still to attack. But let's let them at least show. So I'm going to stand here looking to the right, and I'm going to press the X key, and what you'll see is the animation playing. So there's our sword, and it just starts playing and playing and playing and playing. But now I'm stuck in this state, and I can't move, I can't do anything, but I have a really cool looking attack, which is what I want. So that's how we can run the attack. Again, we don't want the player to walk. We want them just, when we hit the attack key, to just stop moving and then to switch to the correct sprite for the attack and then actually play that attack. What I do want to have happen, though, is that I want to allow the player to be able to hit something with its sword. And here's how we're going to make that happen. I'm actually going to leave our player for the moment. And I'm going to create a new object. We already have it in here. If we look in our set of sprites in the starter project, there's a section called Hitboxes. And in the Hitboxes, there are this collection of sprites that have already been made for you. There's one called S-Bomb Hitbox, and it's just a circle that's 32 by 32 pixels. There's another one that's S-Sword Hitbox. It's 80 by 100 with its origin point sitting sort of centered. If you imagine the player standing to the left of this, that's where the player will be, and then this represents the swipe of the sword. There's something called the Skeleton Hitbox that we'll use later when we want to attack enemies. And it's the same as the bomb hitbox, except it's a different size. And then we've got our trigger hitbox that we'll use to move from room to room. So what we want to do is to create an object that is not going to be visible in the room, but it will function to detect collisions between the player's sword and some other object in the room. It functions the same way our wall objects have worked in the platformer and in the koala game and now in the RPG game. It's just that these hitboxes aren't going to be out in the room the whole time. They're going to come into existence when the player hits an attack key, be in the room briefly for the length of the animation that plays when the player swings the sword, and then they're going to destroy themselves. Okay, so let's get all of that set up. I'm going to create a new object, and I'll call it O Hitbox. And I'm going to give it the bomb hitbox. And I'm going to deselect, well, I'll select visible to start with so you can see how this looks. Okay. I'm going to add a create event And in the create event, I'm going to create a instance variable called damage, and I'll initialize it to 1. I'm going to have another one called knockback that I'll also initialize to 1, and I'll have another one that's going to be an array called target equals, and then it's just going to be empty. Damage is just what it sounds like. How much damage will this hitbox cause to whatever it hits? This damage variable is going to impact the HP on our enemies when we get to that point. Knockback we're going to use in order to cause the enemies in the room to visibly move the opposite direction that they are hit. It's going to allow us kind of a cool visual effect. In fact, we used it in the platformer, the same concept. When we hit the enemy, they kind of flew up into the air, the opposite direction that they were hit. And then targets, this array is going to hold one or more objects that we want to check for collisions. So before, we've just always checked the wall. But with these hitboxes, it may be possible that there are multiple things we want to check for. And in fact, there will be multiple things. There are going to be enemies, and there's going to be grass, for example. Okay? So that's what all this is. This is just setting these up. Then we're going to add an alarm event to this, which is weird because in the create event we haven't set an alarm, but we will set an alarm when we instantiate an instance of a hitbox. In that instantiation, we'll set an alarm, and then this is just taking care of what we want to have happen when the alarm hits 0. And what we are going to have happen is to destroy the hitbox. So instance destroy. All right, and that's it. That's all we need to do for our hitbox. Okay.